I want to take a closer look at three triangles that come out of this picture that we saw in the last video. The one triangle is the one that's got sine and cosine in it. The other triangle is the one that has tangent and secant in it, and then this big triangle up here that has cotangent and cosecant in it. I say the big triangle only because the angle I drew, this one happens to be bigger, but if the angle was bigger, this one would get smaller and that one would get bigger. But anyway, let's take a look first of all at the basic one, where I've got, oh, I'm still in orange. Let's try blue. This angle is theta. The hypotenuse is 1. That means the opposite side has to be the sine of theta. The length of the opposite side is equal in value to the sine of the theta, sine of the angle theta, and the adjacent side, the length of that side, is equal in length to the cosine of the angle theta, because the hypotenuse has length 1. What are some things that this tells me? There's some basic identities here that this triangle just makes apparent to me. One is the Pythagorean theorem, and if I take the side length of sine and square that, and I add to it the side length of the cosine theta squared, then that's going to be the square of the hypotenuse. Well, 1 squared is just 1. Right? There's the Pythagorean relationship. And this is up until just this year, as I was doing a bunch of proof by pictures, it occurred to me there's a lot more stuff in here. I also see, for instance, that some reciprocal identities. What's the cosecant of theta? Well, the cosecant is the hypotenuse divided by the opposite side. Well, that's 1 over the sine of theta. I can see that the secant of theta, which is the hypotenuse divided by the adjacent side, is 1 over the cosine theta. I also see some quotient identities. I see that the tangent of theta, tan of theta, is the opposite side divided by the adjacent side. So sine of theta divided by cosine of theta. And I see that the cotangent of theta is equal to adjacent divided by opposite, so cosine theta divided by sine theta. This picture lets me see a lot of those basic relationships between the trig functions. It's another thing it shows me if I realize that this angle up here is the complement of that one. So this is pi over 2 minus theta. Remember, we're working in radians nowadays, so instead of saying 90 minus theta, I'm using pi over 2. And what this lets me see is things like, what's the sine of pi over 2 minus theta? Well, the sine would be the opposite over the hypotenuse, so that's the cosine of theta divided by 1. There's your cofunction identity. Likewise, I can see that the cosine of pi over 2 minus theta is adjacent divided by hypotenuse, which is just the sine theta. Okay. So there's, 1, 2, 3, 4, 5, 6, 7 identities that I think I see plainly, clearly in this picture, with the hypotenuse being 1. Okay. Then I say, well, how about the other triangles that I had up there? So another one that I had was when the adjacent side was equal to 1, we had that the opposite side here was tangent theta, right? And that the hypotenuse turns out to be secant theta. So what does this tell me about the world? Well, this tells me that 1 squared plus the tangent squared theta is always equal to the secant squared theta. That's just Pythagorean theorem applied to this triangle. But there's some other things I see too, because for instance, I see that the cosine of theta should be the adjacent side divided by the hypotenuse, which is 1 over the secant theta. There's a reciprocal identity. I can see that the cotangent of theta, which is the adjacent side divided by the opposite, is 1 over the tangent theta. There we go. There's another reciprocal identity. Now there's a few other identities that we don't generally write down, but I mean they're here, so I'm going to do them. I can see that the sine of theta is the tangent of theta divided by the secant of theta. Now there's an identity that you don't usually use, but I'll bet you at some point in your homework you were asked to verify this identity, and you'd probably turn tangent into sine over cosine and this into 1 over cosine and simplify. But anyway, There must be something else here. The cosecant of theta is the secant of theta divided by the tangent of theta. Just that one upside down. I mean, it's a quotient identity, just like we had for tangent and cotangent. But there's probably a couple more here. Oh, yes, of course there is. Because if I, again, mention that, oh, yeah, this angle up here is the complement of the one down there. So I can see things like the cotangent of pi over 2 minus theta is adjacent over opposite. It's the tangent theta divided by 1. I can see that the cosecant of pi over 2 minus theta is the hypotenuse divided by the opposite side, which would be secant of theta divided by 1. So there's a couple more of the cofunction identities that we saw early on in the quarter. Right? And now I've got one more triangle I want to look at. One more triangle this time. This time we have the opposite side having length 1. This is theta. Of course, in the picture above, the whole thing's turned around. Actually, I like doing this because I can do this. In the picture that we started with, this looked kind of like this, right? And so now we've got it flipped right side up. Anyway. So, with the opposite side being 1, adjacent divided by opposite, that would be the cotangent. Hypotenuse divided by the opposite, that would be the cosecant. So I have these three sides. Pythagoras tells me that 1 squared plus the cotangent squared of theta equals the cosecant squared of theta. So there's the Pythagorean relationship. Again, this is what I always used to just say, hey, this is a good picture for that identity. But this is a good picture for a lot of identities, because this one also tells me things like the tangent of theta is 1 over the cotangent of theta. Opposite over here. I can see that the sine of theta is 1 over the cosecant of theta. I can see, there must be some quotient things here. I can see that the cosine of theta is the cotangent of theta divided by the cosecant of theta. Again, that's not one of my basic identities that I think of, but it's there. It's in the picture. Adjacent divided by hypotenuse. Okay. And I must have that the secant of theta is the reciprocal of that. Cosecant of theta divided by the cotan of theta. And oh, what the heck, we're here, right? We did it for the other two triangles. Let's say, hey, this angle up here is the complement of that one down there, so pi over 2 minus theta is that angle. And now I can see that this one over that. So this would be, let's start with this one, tangent of pi over 2 minus theta would be its opposite side divided by the adjacent. That's the cotangent of theta. And I can see that the secant of theta, which is pi over 2 minus theta, is this divided by that. That's the cosecant of theta. So for each one of these pictures, I've got a whole smattering here of the basic identities. I think it pretty much covers all of them. The reciprocal identities, I had 2 reciprocal identities for each one. I had 2 quotient, what are these things? Cofunction identities. I had a couple of quotient identities. I had Pythagorean relationship. Every single one of those basic identities that we learned early on in the quarter is either here with the opposite side being 1, or here with the adjacent side being 1, or here with the hypotenuse being 1. This, to me, is the power of the unit circle. You do not yet know the power of the unit circle. Well, you're starting to. It shows a lot of those basic relationships really nicely. So there you go. This triangle, that triangle, and this last one. All of your basic trig identities in 3 pictures.